So here's a max-min word problem. I know it's a max-min word problem because the first four words are find the maximum volume. So find the maximum volume of an open top box given that the material for the bottom costs $4 per square meter and the material for the sides costs $2 per square meter. You have a total budget of $60. So we're trying to maximize the volume. So that should be the first thing we write down. Write down the formula that you're trying to optimize. Now here's the picture. Open top box means there's no top, but there is a bottom. The volume is going to be length times width times height, or x times y. So the volume of this thing is x squared y. That's what I'm trying to optimize. It turns out in terms of two variables, x and y. So I want to get rid of one of the variables. So what stops me from building like the biggest box ever? I only have $60 to spend. So that $60 should equal the cost of the materials. So let's see here. So $60 is equal to, let's look at the bottom. The bottom is x times x. The bottom is x squared meters. And for each meter, it costs $4. So the cost of the bottom would be 4x squared. $4 per square meter, x squared square meters. Now let's look at the sides. That's $2 per square meter. I'm going to need 4 of the sides, and each side has an area of xy. So this is my linking function. This is the function that's going to let me solve for one of the variables. I'm going to pick y. Get rid of y in the function that I'm going to differentiate, and then I can differentiate v with respect to only one of the variables. So I need to solve this equation for, well, either x or y. I'm going to choose y because x is squared here and not squared. So 2 times 4, let's make that an 8. And let's solve this constraint. So I'm going to write that as 60 minus 4x squared. I'm going to bring that x squared, that 4x squared, over to the other side, equals 8xy. And now I'm going to divide both sides of the equation by the xy. So that's going to be equal to 60 minus 4x squared, all divided by the 8x. That equals y. Now I know I can simplify this a little bit. I'm going to leave that till the end here for a minute. But if I spend $60 on the box, that means that here's my equation of y in terms of x. So instead of writing volume as x squared y, I can write volume as x squared y, and this is the y. Now I'm at the stage where I've got volume strictly as a function of x. So now I can take the derivative, set it equal to 0, find the maximum point. So before I take the derivative, if I take the derivative now as it stands, let's get rid of that. If I take the derivative as of now, I got to do product rule, quotient rule. Let's clean up a bit. I can cancel this x with one of those x's. Now I'm going to multiply this x through the top, so that's going to be 60x minus 4x cubed. So I multiplied that x through, and it's all still divided by 8. I could divide each piece by 8, or I could just leave it because I'm going to take the derivative, and I'm thinking of this whole thing as multiplied by an 8th. I think that's what I'm going to do. So let's differentiate. So I can write v prime. What I mean is dv dx. I'm taking the derivative. So that's going to be equal to that 8 on the bottom. I'm just ignoring. It's a constant. The derivative of 60x is 60. Here the 3 comes down times the 4. Subtract 1 from the exponent. And here's the derivative of the volume with respect to x. I want a maximum value, so I want a place where the slope is flat. I'm setting that equal to 0, and now it's a matter of solve this for x. Now I can see, yeah, it was a good idea that I ignored the 8 because I'm going to cross multiply it up here. And when I do that, 8 times 0 is 0. I'm just getting this 60 minus 12 x squared is equal to 0. I'm going to bring this minus 12x over to the other side. So it's going to be 60 equals 12x squared. I can divide both sides by 12. So 60 divided by 12, that's 5. So that's going to give me 5 is equal to x squared. I'm almost there. I got to square root both sides. So x is equal to, now I know plus minus, I'm thinking plus minus. I'm only writing the plus because it's the side of a box. So it's the positive. So x is equal to the square root of 5. Here's the final step though. Don't just stop here and go, oh, x is equal to square root of 5. You have to actually answer the question. What is it they wanted? Find the maximum volume. So I know that x is equal to root 5 meters. My answer should be a volume. My answer should be such and such cubic meters. So I could take this x, I know is root 5 now, and I could plug it into this equation and figure out what the y is. Then I would know what x and y were, and then I could just say, oh, the volume is x times y, and figure it out that way. Or I could take, because I do have the volume formula here, I have the volume formula as a function of x only, I could just take that root 5 and plug it into that formula. I think that's what I'm going to do. So the volume is equal to, and everywhere there's an x, I'm going to put a root 5. So root 5. Root 5 cubed is going to be, I could write it like this, but that's also equal to 5, root 5 times root 5 times root 5, which would be 5 root 5, and 5 times the 4 is a 20. I could write it like that. Can we clean this up a little bit? Oh yeah, I guess so. That's going to be 60 root 5s minus 20 root 5s. That's 40 root 5s. 40 root 5s, so let's take that step here. 40 root 5s divided by 8. 40 divided by 8 is 5. So I get a volume of 5 root 5. And I guess to be like super, super good, I should write that as cubic meters because of units. Now I've answered the question. Any other max-min word problem is going to have the same steps. You write down the function that you're trying to maximize or minimize. It shows up in terms of two variables. You go into the question and find the link between the two variables. That gets rid of one of the variables in the function that you're going to take the derivative of. Now that function that you're going to take derivative of, you're going to take the derivative, set it equal to 0, solve for x, and then the final step is actually answer the question. Make sure you actually answer the question. And that's it.